Hey guys, welcome back to chemistry class for the winter term. And I know we're online right now, but we kind of wanted to start the term off with a bang. So we are going to do a demo today. And this is one of my favorite things about being a chem teacher, is the opportunity to light things on fire and call it part of my job. So the reaction that we're going to be doing today is going to help lead us into our thermochemistry unit. And as you might imagine, thermochemistry, it has to do with the heat of reactions. So every reaction is going to take in or give off heat as one of its products. So thermochemistry is going to tell us about how we can understand the heat taken in or given off by a reaction. So the reaction that we are going to be doing today is called the thermite reaction. It's a class of reactions where we have a couple of metals reacting that give off a whole lot of heat. So this is something that's actually used a lot of times in railway welding when they want to weld two train tracks together, or if you want to cut into a safe, you can use this type of reaction to break in and do all of your bank robbing. I think for legal purposes, I cannot condone any sort of bank robbery. So now, actually, let's talk about the reaction that's going to occur. So we have a couple of things right here. We have ferric or iron 3 oxides. We have some iron 3 oxide, and we have aluminum powder. So now is a good time for your teacher to pause this video and let you consider writing out the balanced equation, including the chemical formulas, and predicting the products that are going to form when we react iron 3 oxide with aluminum powder. Welcome back. So what we're going to do is we're going to actually start setting this up. So we need to weigh out our reactants here. So I'm going to grab my dish and zero it out. And I'm going to put on my safety goggles, which, oh my goodness, given the mask, this is a bit of a challenge, but we're going to rock and roll, yeah? So we have the iron 3 oxide. And we're going to weigh out a bit of it. I don't know, let's kind of... cool, 23.99 grams. So this is in case we want to actually do some calculations later on this term. 23.99 grams of iron 3 oxide. Now we're going to mix together some aluminum powder. And we're going to do, I guess, about a little under 10 grams of this. We'll call it 9.28 grams of solid aluminum powder. So we're going to take these and mix them together. And no real rhyme or reason here, just getting them kind of broken up and into a semi-homogeneous mixture. Oh, look at that, pulling in vocabulary from last term. So I'm going to stir this up just a skosh here, such that we have a good mix of the two chemicals. Now, what we are going to do is we're going to take and put this inside of a clay pot because this reaction is going to throw off a whole lot of energy and heat, and we don't want our reaction vessel to melt or break or shatter or any other dangerous things. So you can tell by the fact that I'm wearing a lab coat and goggles that this is going to be a fun reaction that's going to happen. So we're going to pour our thermite mixture into a coffee filter. And the purpose of the coffee filter is to keep the reaction mixture from falling out the hole in the bottom of the flower pot before I want it to. So we're going to set this into the flower pot, and we are going to tamp it down just a little bit using a pestle. All right, so that's looking pretty good, yeah? All right. The next thing we want to do is we're going to set this flower pot inside a larger flower pot, because from what I read online, a lot of times this flower pot ain't going to make it through this reaction, so we do want to have something to catch it. So I'm going to set these up on a ring stand, our two flower pots nested inside of each other. Did I give you the disclaimer, don't try this at home? The internet said only chemistry experts should be trying it, so don't tell anybody that I'm doing this. So we're going to set it up with a terracotta pot inside another terracotta pot inside a ring stand. Now, what's going to come out the bottom of this pan is going to be molten metal, right? So molten iron metal and molten aluminum oxide. So these are liquid, right? We're going to actually melt these metals. We're going to generate enough heat to melt them. And I can't remember what Wikipedia said the melting temperature of iron was in Celsius, which is the degrees we want to use. However, in Fahrenheit, it was about 2,700 degrees Fahrenheit. So somebody who can do the calculation real quick, go for it. But we're looking at about 2,700 Fahrenheit. So what we need to do, since we're going to have molten metal coming out of the bottom of this flower pot, we need something to catch it in, right? Let's set a pan of science down there, and we have some sand that we're going to mix in just to catch it and dissipate the heat energy that's going to be coming off of this reaction. So let's see, we have our flower pot with the thermite mixture in it, and finally, so this reaction between the iron oxide and the aluminum is not a spontaneous reaction, right? So they are not reacting right now. I don't want to touch it, but I could without burning myself, because these metals are not reacting, right? So we're going to learn about this towards the end of the term, or spring term. We're going to learn about spontaneous reactions. This is not one of them. We need to provide what's known as activation energy. So we need to provide a little bit of heat to get this thing started, and that heat's going to come in the form of a magnesium ribbon that we're going to set in there. And this magnesium ribbon is going to act as a fuse, which we're going to light with the blowtorch of science. All right, so seeing as how the school's insurance policy does not cover us doing this inside, we're going to pause for a second, move this whole setup to the gravel lot, and resume right then. All right, and we're back. We are now coming to you live from the middle of the gorgeous gravel lot right here. I'm not going to lie, this apparatus looks a little bit less impressive now that we get it outside. Looks a little bit bigger and more boomy inside, but you know what? We're going to roll with it and see how this works. So we have our magnesium ribbon inside the thermite reaction mix inside our flower pot, and the last thing that we need is a little bit of activation energy. All right, so the name of this game is we're going to light the magnesium fuse, and we are going to move away pretty quickly. So let's get this going. Another thing that's important, magnesium when it burns gives off UV light. I don't think you can see this through the video, but I am going to try not to look directly at it. Oh boy, there it is. So that light you see is the magnesium burning right now. I think when the thermite lights, you're going to be able to tell when that happens. Woohoo! And you can see in that pan right there, we have some molten red hot iron. So we now have liquid iron sitting in that pan full of sand. So we are going to play a game called Let This Cool Down before we actually touch it. Oh wow, that's, oh cool.
Closer. Oh, actually you can't see very well in the video, but wow, that is really cool.
And you know this game is fun when you take off your goggles to get a closer look at it. It was iron oxide. Iron oxide and aluminum. So we are gonna, against my better judgment, poke this with a pair of tongs.
That was pretty cool. That was funny. I think it would inside. Yeah, this thing.
Yeah, it's pretty cool.
And what we have here is oh, I do not want to drop that and touch it. So we have a piece of now cooling iron and aluminum oxide. So we melted both of the metals into each other, and I think they're actually probably encased in a layer of glass that formed when the sand around them melted. So yeah, this is pretty warm right here. So we're gonna not touch this, and we have used the heat coming off of this We have used the heat coming off of this reaction to melt the aluminum or the aluminum oxide and the iron. So that right there is the thermite reaction, and I hope this has caught your interest. And we're going to talk about what actually went on in this reaction over the next couple of weeks.